Okay, well, I'm going to start with a quick introduction of Emily. Um, so Emily worked with us, was it like almost 2 years, or was it about 2 years?
It was about 2 years, yeah.
Yeah, it's about two
Two
years
summers.
in your last, yes, in your last 2 years of undergrad at Cal. And you became our go-to Unity person. So all of our students who were learning like 2D and really elaborate game design, we ended up shunting over to Emily. And it just so happened a lot of them were like adolescent boys. So most of your student ended up being like, I don't know, kids between like boys between 12 and 14, but they stayed with you for a long time. And, one of them, well, two of them actually became CITs, like summer camp code coaches in training. And then one of them we actually ended up hiring, as you know, Jake. He was one of our summer camp coaches, and he was a long time student of Emily's. He would adjust his schedule, like make every change in his schedule possible to make it work with it, to be able to work with Emily. And over the summer too, he was working with her like multiple times a week. So I'm just saying all this as a testament to how well thought of and how well received Emily's instruction has been. She has also taught other Unity workshops for the coaches in the past. So I think you guys are all in really good hands. So I'm just gonna, yeah, send it over to Emily and stop talking. Thank you, Emily.
Thank you so much for the introduction, Lena.
Yeah, thank you for agreeing to come back from your full-time work to be with us.
It's really great to be back at Coder School. I miss my students so much. To add on to the introduction, I took the game design and development decal back at Cal for a semester, and that's kind of where I got my start in Unity. After that, I did a lot of solo projects, a lot of hackathons, and then I taught the virtual reality decal, which is also in Unity at Cal. And then currently, I'm not working with Unity, but I'm working with the Unreal Engine, which is Epic's version of Unity. It's a bit more for like AAA games and less for like mobile games for Unity. So that's been kind of my experience. It's been a bit of a while since I've touched Unity, but I've kind of dusted off the skills, looked up some more information about like Unity 2020, which is what we're going to work with. And so we're gonna go ahead and get started. So I think everyone's downloaded Unity 2020. Let's go ahead and I'm going to share my screen. We're just going to go ahead and open it up. So usually what I like to do when I teach students, get my Usually what I like to do when I teach students is to go through the Learn with Code program that Unity has. Unity actually has a lot of tutorials and lesson plans for people that are new to programming and new to Unity. But for this, because I've already done workshops for the Coder School with those plans, I'm going with a different workshop. This is called the Roll a Ball tutorial. And by the end of this workshop, the idea is that we're going to build this whole game from scratch instead of using, a template or some current art. And we're going to be able to roll a ball and collect collectibles. There we go. So if everyone could just go ahead and open up their Unity Hub or whichever version of Unity, whichever way you had installed the Unity 2020 version. I used Unity Hub. I'm gonna exit out of this project. Go ahead and open up Unity Hub. And we're going to get started by going through the Learn section here. And as I'm going through this, feel free to just unmute and ask questions at any time. I want to make sure that everyone's following along. I tend to go a little bit fast, so feel free to slow me down if you get lost at any point. Okay, so we're in the Unity Hub. If you're teaching students that don't really know how to code or program, but they really want to get into Unity, I had a couple students like that that just wanted to jump into Unity right away. First, I'd recommend not doing that because Unity is kind of a difficult tool and it would be difficult for new programmers to get into it. I really recommend teaching Unity to students who already know Java or other object-oriented programming languages. But if you do have those students who are insistent on learning Unity, I would get started with the Creator Kit, FPS, or Creator Kit Beginner Code. And a lot of these projects, the Creator Kit projects, or even the beginner scripting projects, they're all a lot of like building blocks to Unity and to programming. I think there's a lot of like drag and drop coding as well. So those would be a good way to introduce Unity without jumping right away into the coding. The micro games are also really awesome for that. What we're doing is the roll a ball tutorial, and there's actually no project to download here as opposed to the other ones that you might download and install. Instead, we're going to go to projects. We're going to go ahead and click the new button. Then we're going to create a new project. So we're going to go with, so there's a lot of templates that you can use with Unity. Oh, let me make sure that I choose 2020. So we're all in the same version. There's a lot of different templates to use. We're going to go with the universal render pipeline, and that's generally the template that I like to use because it'll allow me to export the game onto different platforms like Windows, Mac. You can go mobile with it. We're just going to call this project whatever you want. I was working on this project earlier, so it already exists for me. So I'm just going to look Rollerball too and make it easy. And go ahead and choose a location for your project. I like to have a location just on my C drive for all of my programming projects. You might want to put it in the documents folder, whatever works for you. And then we're going to go ahead and click create. And so here it might take a while for Unity to create a project. Go ahead and just give me a thumbs up on these Zoom emojis once you're at that stage where the project opens up for you. Cool, thanks for the thumbs up, Julia. And I think we're still waiting for a lot of people to have their project open up. But if you have your project open up already, you should be in the sample scene that Unity has for the universal render pipeline. And feel free to just go ahead and explore the scene. Also, can we go around? What has been your experience with Unity and your experience with programming? And has anyone actually, let's do a show of hands. Has anyone here had experience with Unity before? Okay, Nick, Julia. Okay. Has anyone have had experience with Java? Java, okay. Most of us have Java. That's good because, okay, has anyone had experience with C Sharp? A little bit, some people. Okay. If you know Java, I would recommend, if you know Java, you're good to go. I'd say the languages in terms of Unity are pretty similar. Okay, so, and is anyone else still waiting for Unity to open up their project? Cool, awesome. So this is the sample scene. Over here, we have the toolbar. This is the hand tool. It'll kind of allow us to, okay. I'm in the game window right now, so I can't actually interact with anything. I'm gonna switch over to the scene window. That might be the problem for any of y'all as well. So I can go ahead and, Steven, is your hands up, or are you frozen?
I'm pretty sure they're frozen. They've been stuck like that for a second.
Okay, no worries then. You can go ahead and use the scroll wheel to zoom in and zoom out. You can use the hand tool to kind of move yourself around. If you right click, you can also rotate the camera. And if you press left click and right click at the same time, you can use the hand tool here. You can switch between the other items on the toolbar by going Q, W, which gives you the move tool, E, which is the rotate tool, and so on. Feel free to just kind of run around the scene here and get used to moving around in Unity. The view that we're in right now, actually, I just remember that we may not have the same view. If you'd like to follow along with exactly how I'm doing, go ahead and go to the top right corner here and go to layout. I am in the tall view. And that's kind of my favorite layout. If you're comfortable with Unity, feel free to choose whichever layout you like. Default is also a nice one, but I am in tall. Okay, so this view right here is the scene view. If you click a tab over, this is the game view. This is what your player would see once they actually play the game, activate the game. There is a play button and a pause button over here for if you want to start simulating your game. Get out. Okay, here. We have a hierarchy view, which actually shows us what is in the scene view, specific items in the scene view, such as the camera, the light. We also have the project folder over here. And here we have the inspector. So I'll just be using these terms, and then as long as we have the same view, I'm sure we can all get used to it. We're going to go ahead and create a new scene. So on the top left corner, go ahead and go to new scene. And we're going to create a new scene called, well, just hit create scene, choose the basic template, and we're going to go ahead and save this as, let's just call it mini game or game. We can just call it game. So what a scene is you can think of it as another level or a way to kind of save certain settings or environments that you have. Every level in a platformer game would be a new scene, and maybe your start menu would be a new scene, and maybe your end credits would be a new scene. We're going to go ahead and create a new scene here, and we're going to create a new level from scratch. I'm going to go ahead and expand my project folder a little bit. There's a lot of items here that we're not going to be using because they come from the sample scene. So I'm just going to go ahead and create a new folder. And I'm going to call it something like template. I'm just going to drop every item except for the game scene that I just created into that folder. We're just going to try to keep our project folder as clean as possible. And whenever you teach Unity to your students, try to make sure that they keep everything organized and clean as well. And then we're going to create another folder. This is just going to be called scenes. Every time you create anything, you're going to want to just drop it into a folder to keep everything well organized. So I dropped game into my scenes folder. Again, let me know if anyone has any questions if I'm moving too fast. And if I'm moving too slow, feel free to give me that one reaction to that's like, speed up. Okay, awesome. So now I have a scene. In my hierarchy, I have a main camera and I have a directional light. We're going to go ahead and start by creating a ground for our ball to roll on. We're going to go ahead and right click in the hierarchy. We're going to go to 3D object and we're going to select plane. So Unity has a lot of basic primitives, shapes for programmers to use, just start creating. So you don't necessarily have to work with an artist to create assets for you to use. So we're just going to go ahead and create our own plane. We're going to call it ground. The moment we created the plane, it shows up in our scene. in our hierarchy, and then the inspector automatically selects it and shows us all of these details here. We're going to call our plane ground, and then there is a transform component over here. And what that means is just, where is the ground positions and what is its rotation and scale. We can go ahead and just reset the transform. That's going to place everything back at origin 0, 0, 0. And we can go ahead and we make this ground a little bit bigger. We can go ahead and scale it on the X and Z axis. I'm going to set the scale to be 2 and 2. It is a plane, and if anyone has taken, I think it's CS 162 at Cal or computer graphics, if you change the Y scale at all, nothing will happen because this is just a one plane surface. So this is going to be our ground. And we're going to go ahead and now create a player. Go ahead to go and choose 3D object, sphere, and our player is going to be a ball. It's going to roll around on the ground. Going to call it player. We're also going to reset the position here. And now I have a sphere that is actually like embedded in the middle of my ground, which is not ideal. So we're just gonna go ahead and zoom in on the sphere. And what we can do is we can move around with the hand tool and we can rotate, or I can just click on it in the hierarchy and press F. And that will place the sphere into frame, F for frame. I'll zoom out a little bit right here. Okay, so I think my sphere is nice, but I'm going to want to move it up a little bit. And all of the primitives in Unity are essentially 1x1 units, Unity units. What those units are in real life, in most game engines, there's really no direct correlation. It could be 1 centimeter, it could be 1 meter, it could be 1 mile. It's really up to you as the game dev. So they're called Unity units. And because I know the sphere is 1x1x1, I'm just going to go ahead and move it up on the Y axis by 0.5. So that's going to place my sphere just directly above the plane. Awesome. And if I go into game view, yeah, there it is. Let's go ahead and look at the directional light. What a directional light is that it's a kind of universal light source that doesn't quite have a position. It's not quite like the sun where it comes from a specific position. If I move this wherever, it doesn't really change how the light is. But the rotation of the light does matter a lot here. So I think I want to go ahead and make the light a bit more dramatic. Feel free to change this however way you want to, but let me just do a quick demonstration. If I change rotation here, and I can do that by changing the numbers directly, or I can hover over the X value here and just kind of drag my mouse all the way to the right or left. You can see the light source kind of rotating. It kind of looks like it's going from sunset to sunrise. Let's go ahead and move it back. I'm just gonna reset my transform. Go with something like that. If you place the light at a certain angle, like 50-50, you can see that there's like this blue tint that's happening, and that's just because of how the reflection and light bounces work with the skybox that's happening in the background. So I'm just gonna slightly adjust this so that blue tint doesn't exist. And I can change the color of my light however I want to here. Okay, so that's the lighting, that's the ground, that's the player. Main camera, we'll go over that later. The next thing is that this game looks pretty boring so far, and we're not going to be doing too much processing on it because I'm not an artist. We're focusing on the programming aspect. So what we're going to do is just change the material a bit, like the texture a little bit. Back in my scene view, I'm gonna go back a level on my assets folder and create a new folder called materials. And I'm gonna start creating materials. Go ahead and right click, create, go down to material. And I think the first material I want to create would be maybe the ground. They have a couple of different options here. Has anyone ever taken a computer graphics class? Okay. Oh, so you have, right? Okay, awesome. Well, you might know a couple of things about like the surface type or a render face, if it's should receive shadows or whatnot. I'm not too into graphics, so I think the only parameters I would touch would be the base map, which is the coloring, kind of like the metallicness of the object, and maybe how smooth an object is. That is it very shiny or is it more like matte? So this is going to be the ground for me. I think I want to go with a more kind of grayish neutral color. Probably don't want to be too metallic and smooth this. I don't think I want it to be too shiny or smooth either. So I'm just gonna adjust it to however. And then to attach it to the ground, I can go ahead and just click on it, click on the material in the project folder and drag and drop it to the ground. Make sure you don't drag and drop it to the player, but it's specifically over the ground here. So now I'm gonna let go of my mouse. There we go. I'm gonna create another material. I'm gonna call this however y'all want to name it. I think I want to go with a more fun color here, like a purple maybe. Yeah, I like purple. Awesome. No metallicness, but I want it smooth and shiny so it really catches the eye of the player. You can kind of see how it looks in the project folder, which is cool. I'm going to go ahead and drag and drop it not to the ground, but to the player. Whoa, look how shiny it is. Love it. Okay, cool. Go ahead and choose whatever color y'all want to. At the end of this, I'm going to ask you to send a screenshot into the Discord channel just to see what cool combinations y'all have made. Okay, so the next step here is how do we actually get the ball rolling on this game? Haha. In order to do that, how this game is going to work is that we want the player to use the arrow keys to move the ball around, interact with the ground, collide with the walls, maybe pick up collectibles. And in order to do that, we have to be able to track the player's inputs. So we are going to go to the packet manager. So that's in the window section right here. We can go to packet manager. And Unity likes to put any extraneous items or packages into the packet manager, and you'll have to download it separately. So go ahead and go to packet manager, click on Unity registry to be able to select or search through all of the packets. So a couple of really cool items here. And what we're going to look for is the input system. Let's go ahead and click install. You might get this warning message. Go ahead and just click yes. And go ahead and give me a thumbs when your package has installed and your game has relaunched. Okay, I see Nick is good, Nico is good.
Sorry, I'm in the package manager. What's the name of the one that we're downloading again?
Yeah, it is called the input system.
Okay, thank you.
Sophia, were you able to find it? Okay,
Yes, I've got it. Thank you.
cool. Is anyone else still waiting for Unity to install the package? Okay, awesome. So now we're going to add player input to the player. Go ahead and click on the player. In order for us to have that input, we're just going to go ahead and add the, I believe it is the input field. We're going to go ahead and click on the player and go into the inspector, and we're going to go ahead and add a component. I'm not sure if I mentioned this, but a component is just an additional detail that each of these game objects has. So it has a position, there is a mesh filter, there's a mesh renderer, there's a sphere collider, you know, like the boundaries or the hitbox of the sphere, and the material, which we've added earlier. We're going to go ahead and add, I believe it is the player. Yeah, there we go. We're going to go ahead and click add component, type in player input, and we're going to add the player input component. Okay, and once we have that, we're just going to go ahead and click create actions. And that's going to open up a little dialog box here. We're going to create a new folder, because we're always creating folders, called input actions. Double click it. Just go ahead and, yeah, let's call this player ball input actions. Now we're going to go ahead and attach that setting that we've just created to the player inputs. It says actions, none. We're going to click on this button right here, this little target symbol, and select the player ball. So that's going to allow us to track the user inputs and then send messages to our player ball for us to receive and do with it as we like. The other thing that we're going to want to do is make sure that our player adheres to physics. So it collides with objects, it moves with physics in mind, like with gravity and with drag. So we're going to go ahead and turn it into a rigid body. We're going to add a rigid body component. And that allows us to set any mass, any drag or angular drag. We definitely want it to use gravity. We don't want it flying off. We can change like if it's kinematic or not, and any other constraints, like if we wanted to freeze the position or rotation. We're just going to add a regular rigid body. We're not going to change any of the settings here. And then the last thing we do, we have the player inputs, so the ball will do as the player does. We have the rigid body, so it adheres to game logic and game physics. And the next thing we're going to do is we're just going to go ahead and create a player controller script. Player controller is kind of the standard name that Unity will use for a script that controls player movement. Once you type it in, Unity's going to be like, oh, there's no component that's called player controller. So we can go ahead and create a new script out of that. Click create and add. Then if you open up go back to your projects window and check out your assets. You can kind of see that the scripts is just hanging out right here. So we're going to create a new folder and call it scripts. We're going to drag this player controller script in there. If you click on it in the project folder, we can actually see in the inspector view here the script. We won't be able to edit here. We're going to double click the script or right click open to open it in Visual Studio, which is Unity's default editor. Okay. Is anyone not ready to move on? Good to go? Awesome. So because we use this, okay, so every C# script and Unity script that you create will come with this template. It's going to have a class that's based off of the name you gave the script. It's going to inherit from model behavior, which says that this is a part of Unity and has a couple of Unity specific functions, such as this start method and this update method. In Java, also, we have these import libraries, but in C# we actually have something called a namespace, and we use a namespace. This is essentially the same thing as import library in Java. And then we also have these default functions. We have the start function, which is called before the first frame update. And we have the update function, which is called once per frame. We don't actually need the update function for this, but we do want a start function. We're going to initiate it with a rigid body, actually. We're going to go ahead and create a variable called rigid body RB. We gave the player a rigid body, and we actually want to use that rigid body to kind of enact a force upon it in order to get it moving. So we're going to go ahead and create that variable here. Players. And we're actually then going to want to set the variable inside of the start function before we do any processing with that variable. So in order to receive it, we're going to call this .gameObject.getComponent. Okay, so this is actually like the trickiest thing for all. Back when I was teaching Unity, this was the most difficult thing to teach. It was, how do you retrieve something that is a component in the Unity editor and then access it in script? And I think a lot of students get confused about why there are so many dot calls right here. So I'm just going to break this down before we shorten it. So this is going to refer to the script, player controller. Game object is going to refer to the game object the script is attached to. And then all the game objects have certain functions such as get component. And we're just going to get the component type rigid body. Then we end with these parentheses to call the function. Then once students kind of understands this whole call, then I like to shorten it by saying, well, Unity and C# is pretty smart. We really just need to write get component rigid body. But it is kind of important to go through that to make sure that students understand, you know, all the steps and all the pointers it takes to get to this part. Cool, so now we have a rigid body. Because we use the input system, we also have this private void on move call. We're able to get this from the inputs manager that we've installed. And it takes in an input value, movement value. So essentially what happens here is that anytime the player uses the arrow keys to move, we'll actually get a movement value, which is like an X or Y movement value from those input keys. We're going to go ahead and this is going to be called every time the player moves. So I'm going to want to do something with that. So let's go ahead and just grab the movement vector. We're going to say movement value dot get vector 2. Input value is a Unity specific class. If you're ever interested in exactly what a Unity class is, the Unity documentations are really thorough and really awesome. So feel free to look that up. Okay. So now we have the on move, and now we have this kind of movement vector that we're holding onto. We generally don't want to, anytime we do a movement, we actually want to make sure that it's by frame. So we create the movement in the update function. And then in Unity, there's a specific update function that's always used when we are talking about physics, which is fix update. Because this will actually happen after all the physics calls have been calculated. So in private void fix update, we're actually here going to want to say rb.addForce movement vector. Actually, we're going to want to create a more specific vector here. We're going to want to specifically retrieve the x and y variables. We're going to create a private float movement x and a private float movement y. And here we can then say movement x is equals to movement y is equals to movement vector dot y. So every time the player moves, we're going to save their x and y movement into these private floats. And then here in the fix update, then we're going to want to specifically use those floats to move to add a force to the player. Actually, I'm gonna pose this as a question for everyone. So let me know when y'all get to this stage and I'll pose this question. Okay, so with our player ball, what we want to do is use the arrow keys to move the ball on this horizontal plane. So we do want to keep track of the movement X, and we want to keep track of the movement Y, but we also want to make sure that the ball never goes up or down through the plane. And then keeping in mind Unity's system here, we have X horizontally, Z is horizontally, and Y is kind of this up and down. Actually, let me check. I believe X is left and right, and Z is back and forth. So could anyone tell me where I should fill this in? What rb.addForce does is it says given an X, Y, and a Z, we're going to go ahead and move the ball in this direction. The X, Y, and Z direction. And then what the movement X and movement Y here does is this is going to give us the left and right direction. So I believe it's -1 for left and +1 for right. And what movement vector dot Y does is going to give us the up and down arrow key direction. So +1 for front, -1 for back. So keeping that in mind and keeping in mind that our camera is going to be at an angle up and we don't want the ball to jump up and down, what should we put here in the rb.addForce?
Emily, you have a question from CO.
Oh, CO, you just, okay. Thank you for the comment. So CO said, movement X and then movement Y. Oh wait, she just changed the, Okay, movement X, 0, and then movement Y. And yeah, that actually is right, because what we want to do is make sure we go left and right, which is going to be on the x-axis. But with our movement Y, instead of actually jumping up and down, we're going to want to move back and forth instead. So yeah, we're going to actually switch out the Z with the Y. And in the middle here, we're just going to want to keep that as 0. So yeah, thanks for answering, Sita. There we go. And now we could go ahead and go back to Unity here. Oh, okay, I'm getting an error. So whenever I go back to Unity, they're going to compile the script and they're just going to yell at me in this kind of red font here. The type or namespace name input value could not be found. So I was actually missing a namespace call. So right here at the top, we want to make sure that we are using Unity engine.input system. Cool. That fixes the variable. Okay, now let's go back to Unity. I'm going to go ahead and click on play. If I go ahead and use WASD or the arrow keys, I can move the ball around, which is kind of cool. Okay, there's something that's really frustrating me though about moving this ball, and it's the speed. It's really slow. So in order to fix that, we're going to create a speed variable. So at the top here, we're going to go ahead and create, we're actually going to create a public variable. So I'm going to place that above all the other variables, a public float speed. I'm going to set that to 0. And so in Unity, when you create a private float versus a public float, when you create a public variable, it actually exposes the variable to the editor. We're going to go ahead and see what that looks like in a second, but let's go ahead and do something with this first. Now that we have the speed, in fix update, we have this rb.addForce. We're going to want to multiply this by the speed, but we're also probably don't want to multiply it individually. So what I'm going to do is I'm going to create a vector3 movement, which is equals to a new vector3. So I can go ahead and instantiate this new vector3 and copy and paste this here. And we're going to say movement times speed. And then now in Unity, we're going to click on the player. And if we scroll all the way down to where the player controller component is, the script here, we see that the speed variable is actually exposed now, which is so cool because now I can go ahead and change it to something like 10. And then when I'm in play mode, I can actually play it and test it out. And here I'm like, well, I don't really know if I like this speed. I can go back to the inspector and instead of changing to 15 instead. I can just kind of play around with it. What would happen if I change the speed to 50? Okay, that's a lot. The biggest concern with that is that once you exit play mode, if you make all these changes and you exit play mode, it actually resets all the changes you made. So make sure you only do experimental changes in play mode. Get out of play mode before you say, okay, I definitely want my speed to be something like 15. And that's decided. Okay, cool. The next thing that really irritated me about kind of playing this is that with this camera angle, I can't really see too well what's happening. You know, I mean, it looks really cool. I think my material is really shiny, but I think I want the camera to be a little bit higher up. So what I'm going to do is I'm actually going to adjust the camera angle. Let's go ahead and I'm going to stay in game mode so I can kind of continue seeing what my camera will actually look like. let's go ahead and move the Y up, move the camera up a little bit. And then we're gonna wanna rotate the camera down so we can actually see the player. So I'm gonna rotate it down to about 45 degrees with the X rotation. Okay, and so this is kind of the typical camera setup for any top-down 3D games, like a 3D platformer. In other games, you might want to attach the camera to the player. So every time the player moves, the camera follows the player around. But I think that's not going to work very well because of the nature of our character being a ball. You know what I mean? So what we're going to do instead is we're going to create a script on the main camera, and we're going to say wherever the player goes, the main camera is going to follow to some degree. So we're going to go ahead and add a new component. It's going to be a new script, and we're going to call it something like camera controller. Go ahead and create that script. Let's go back to assets and move the camera script to the script section. And then open up the script. Okay, so in order for the camera to actually follow the player around, we're going to want to have some reference to the player. So I'm going to create a public game object player. And this is going to be what is referencing the player. And then in order for so what we're going to want to do is as the player is moving, the camera is also updating its position relative to the player. So wherever the player goes, the camera goes. And we're probably going to want to do that in update. And we're actually going to want to do that in late update. So there's update, fixed update, and late update. The player is moving in fixed update. And if we set our camera position to fixed or regular update, then the camera is always going to be a little bit slow. If we do late update, that occurs after all, the first two processes their calls. So this is going to be right after fixed update is called on the player. So here, we can actually change the camera position by going transform.position equals to something here. What we want to do is connect it to the player position somehow. So we can say player dot transform, the transform component dot position. If we set it equals to the position, let's go ahead and test out what that looks like. Oh, the variable player camera controller has not been assigned. Just got that message here. Make sure to click on the main camera. We have this exposed variable parameter right here. We're going to go ahead and drag and drop player into that value right there. So one more time, just player, drag and drop, boom. Now when I hit play, the camera is set to the player position, and you can kind of see the problem. We're directly on the player. So what we're going to want to do is kind of create an offset. Now I don't really like hard coding those values, so what I'm going to do is I'm going to create a private vector3 offset. And I'm going to say whatever my camera was at the beginning of the game is going to be the offset. So I'm just going to go offset is equals to transform.position. So the position of the camera's transform, or so the position of the camera minus player.transform.position. So in the future, every time we calculate the camera, we're just going to add the offset to the player transform position. Now if I go back, I can move my player and my camera falls. And it doesn't rotate alongside with the player as well. Do we have any questions here? Has everyone been okay with following along? Okay, cool, awesome. Okay, we have about 5 minutes or so left. So we're just going to quickly wrap up by creating the walls of this game. So I'm gonna go back to my scene view. I'm gonna kind of move around. Actually, I want to click on the ground and hit F to focus over the ground. There we go. So I want to create walls. And to do that, I'm going to first create an empty game object called walls. This is kind of a typical Unity workflow. You can go ahead and create an empty game object to act as folders to organize your hierarchy a bit better. So game is a folder, we're gonna have walls as a folder. Another folder might be something like the environment, enemies, and so on. So I'm gonna go ahead and click on walls again. Now I'm gonna go ahead and do a 3D object. Let's create a cube as a wall. Wall. If I go ahead and click on this and press F to focus, it's pretty small. I think we're gonna want to scale it up, something a lot bigger. Just gonna go ahead and play around with the numbers until I have a good size for the wall. Something like this would work. Yeah, something like this works perfectly. 21 will work. Let's make the wall a little bit higher. Not that high. 2, that will work. Then I'm just gonna go ahead and move the wall back. Make it 10. Easier if I just change the rotation. Of the wall along the y-axis. Oh, hello. Can everyone hear me again?
Yes.
Sorry, I think I disconnected for a second there. Can everyone hear me okay?
Yeah, we can hear you.
Can you hear us, Emily?
It's a good thing she made it through most of the hour.
Yep. Yeah, I think this is pretty good right here.
Hey, Emily.
Hi. about that.
That's okay.
Okay. Let's see if we can wrap this up the next couple of minutes. Extremely sorry. So I think as I was saying before, the corners don't really like connect that well. So we're just gonna select all this by selecting the first wall. Should select everything else. I'm gonna change my scale by 20 points.
Thanks everyone for bearing with this. I know it's 8 o'clock, and do you all feel like you're at a point where you can kind of keep going and with the tutorial? Okay, I'll go somewhat of a place to start. Okay. All right.
Hello, is everyone hearing okay?
Hi, Emily.
I'm so sorry about my internet problems.
That's okay.
Okay. Since it's 8 o'clock now, I think this is a good spot to stop at, but this is not the full tutorial. So I thank you everyone for coming and joining. I'll go ahead and send out the rest of this tutorial on Discord afterwards. I think we've covered a lot today. We've covered how to kind of build an environment from scratch. We covered player input, which is huge. We kind of covered like the collision with the rigid body. And then the rest of the tutorial is going to talk about creating collectibles. How do you have objects that interact with each other? And then I think also a bit of user interfacing like text on screen, how to keep track of a score. So yeah, thank you so much for coming along, and I'll stay here for a few minutes after if anyone has any questions. And then Lena, I know you mentioned about maybe students sending a screenshot of the projects that they've made. Is that
Oh,
something?
I think we're good. I think everyone was pretty engaged here, and yeah, I think we're good.
Okay,
Yeah. Yeah.
Cool.
Awesome. Thank you. Thank you so much, Emily. And then when we're ready for round 2, we'll be in touch with you to see if you'd be willing and able to do another round part 2 with us. Something taking it to the next level.
That sounds lovely, and I hope everyone got comfortable with Unity and you're ready to showcase it to your students.
Yeah, thank you. Awesome. Thanks, everybody. Have a great night. Thanks for meeting us on a Monday. And thank you again, Emily, for taking time out of your work week to work with us too. We really appreciate it. It's just so nice to hear your voice again.
It's been a while, for sure.
Thank you. Bye,
Thanks,
everybody.
everyone.
Thanks, Nick. Thanks for coordinating and for getting the recording up.
Thank you.
Thanks.